Good day. Today I'm going to show you how to get the equation of the parabola and the hyperbola and the exponential graph as well. Whenever you're given a situation where there is only one unknown, if you check B is known, C is known, but only A is not known. Whenever there is one unknown, it's very easy to find it. All you need to do is to substitute the given point in order to get it. So we're going to say 5 is equals to A into 2 squared plus 5 into 2 plus 3. And this is going to give you 5 is equals to 2 squared 4. So it's going to be 4a plus 10 plus 3. And 10 plus 3 is 13. So it's going to be 5. If we take that 13 to the other side, it's going to be 5 minus 13 is equals to 4a. And then from there, 5 minus 13 is negative 8. So negative 8 is equals to 4a. And if we divide both sides by 4, we're going to get a is equals to 2. So we're going to get negative 2 actually is equals to a. So we found our a is that easy. So whenever there is one unknown, all you need to do is to substitute the given point in order to find it. Here is another example. Now in this case, we've got two unknowns. So a and b is not known, but c is known. So what do you do in this situation? If you are given 2 points, then you have to substitute both of them and solve simultaneously. What am I talking about? For instance, let's substitute the first one. So if you substitute the first one, it's going to be 5 is equals to a into 2 squared plus b into 2 plus 3. And let's just simplify this equation. So this will in turn give you 4a plus 2b plus 3. And if we take this to the other side, we're going to have 5 minus 3, which is 2. So when I have 2 is equals to 4a plus 2b, and if we divide everything by 2, we're going to get 1 is equals to 2a plus b. So we've simplified this equation. Then we substitute the second point that we're given. So we're given a point here, an x-intercept at 1. So it means the y value is 0. So the other point that we're given is actually 1 is to 0. So when we substitute, it's going to be 0 is equals to a into 1 squared plus b into 1 plus 3. So we're going to have 0 is equals to a, because 1 squared is 1 times a is just a, b times 1 is just b, plus 3. So here we've got two equations. So we're going to have equation 1 and equation 2. So we're going to solve simultaneously. So I'm going to use the substitution method. So I'm going to create my third equation by making b the substitute of the formula. So this is going to be b is equals to 1 minus 2a. So this is going to be my equation 3. And then I'm going to substitute equation 3 into 2, the unmanipulated one. So it means wherever I see b in the second equation, that's where I have to put this, since b is equals to that stuff. So it means 0 is equals to a plus 1 minus 2a plus 3. And then when we solve, we want to get, let's take the letters to the other side. So we're going to get negative a plus 2a is equals to 1 plus 3. And this is going to be a is equals to 4. So since we found our a, we can substitute into any one of the three equations to find our b. So the easiest equation to substitute is obviously the manipulated one. So it means that b is equals to 1 minus 2 times 4, which is 1 minus 8, which is going to be b is equals to negative 7. So I found my a and b, which is negative 7. So whenever you have got two unknowns and you're given 2 points, then you substitute those two and solve simultaneously. You substitute the first one in order to create the first equation, and then substitute the second one in order to create the second equation. So here we're given an exponential graph, and we're asked to find the value of a and q. Basically, we're asked to find the equation of the exponential graph. So what do? So with the exponential graph, it's easy. All you have to do is to find q first, and we know that q is the horizontal asymptote. And if we look at this stuff, an asymptote is a line that the graph approaches but will never touch. So it is negative 1. So it means q is equals to negative 1. And then now we need to find a. So basically we have f at x equals to, so we've got ax minus 1, since we found our q, which was minus 1. So now we have one unknown, and every time there's one unknown, all we have to do is to substitute. Basically, in all functions in the parabola, hyperbola, and exponential graph, Whenever only a is not known, you just have to substitute a point and solve. So we're given an extra point there, so we substitute it. So it means 7 is equals to a to the power of x minus 1. So if we take this to the other side, we have got 7 plus 1, which is just 8, which is equals to a to the power of x. So if we break this down, this means 2 cubed is equals to a to the power of x. Or rather, I actually forgot to substitute the x value. We're supposed to substitute the x and the y value. So let's substitute. So it means 7 is equals to a to the power of 3 minus 1. We take this to the side. It means 8 is equals to a to the power of 3. And then when we break this down, of course, it means 2 to the power of 3 is equals to a to the power of 3. And then it means since the exponents are the same, the bases must be the same. So a has got no choice but to be equals to 2. So that we have found our a. So this time we're given a hyperbola. So whenever they ask you to find the equation or they ask you to find the values of a, p, and q, it's the same stuff. So whenever they ask you that, it's more easier to find the asymptotes first. So we'll say p is equals to, so this relates to p. So here it's negative, it's actually 4. So we have to get a number such that when we substitute there, it will end up being the opposite of that, because we don't want to have x plus 4 there and also here's plus 4, because usually it contradicts. Usually it's supposed to be, if here's plus 4, that's supposed to be x minus 4. So it means p is actually supposed to be minus 4, so that when we substitute it there, we'll have minus 4, while it's in the graph is plus 4. So our p is actually minus 4, and then q always has to remain the same. It doesn't have to contradict with the graph. So if the horizontal asymptote is 2, it means q must be 2 also, so that it's going to be plus 2. So we have found the values of p and q. So it means f at x is equals to a over x minus 4 plus 2. So now we've got only one unknown left, which is a. And whenever we've got one unknown left, all we have to do is just to substitute a given point. So let's look for an extra point that was given. So the extra point that was given is this stuff. So it means the y value is 3. So we have 3 is equals to a over x minus 4 plus 2. So now let's take this to the other side so that it can become 3 minus 2, which is 1. And then from here, whenever we have this, we just cross multiply. So this means it's going to be x minus 4 is equals to a. If this number was 2, it was going to be 2 times x minus 4. The whole thing would have to be in brackets. If this was a 2, for instance, if this was a 2, we would have to multiply the whole thing in bracket, because this 2 is going to be multiplying the whole thing. So we're going to have to put it in brackets so that we're going to have to distribute it. But it was indeed a 1. So since it's a 1, it's going to become x minus 4 is equals to a. Yeah. So now we're given a hyperbola. So if they say find the values of a, p, and q, it's the same as them asking you to find the equation. So they can ask you to find the equation, or they can ask you to find the values of a, p, and q. So we've got 3 unknowns there. So usually we start with the asymptotes, because the asymptotes are easier. So we know that p has to relate with this stuff. So p has to be equals to minus 4, y negative 4, so that when we substitute it there, it's going to be x minus 4. It always has to be different from what it is on the graph. If it's x plus 4 on the graph, will be x minus 4. If it's x minus 4 on the graph, it will be x plus 4. The reason I'm mentioning this is because sometimes they can put a plus, sometimes they can put a minus. What if they put a minus? If they put a minus, it means p will no longer be. So if it was a over x minus p plus q, if there was a minus, it means p will not longer be a minus 4, because if I put minus 4, it's going to be x minus minus 4, and it's going to end up being x plus 4, and it's no more contradicting with the graph. It's not the same, which will be wrong. So it means this time p will be 4. So whenever you choose a value, you have to choose the sign in such a way whereby when you substitute it, the end product will contradict with what it is on the graph. So p is negative 4, and then q is the horizontal asymptote, which will be 2. So with Q, it always has to agree. But with P, it has to disagree. I'm talking about the signs. If on the graph it's 4, on the equation, it will be a -4. But with Q, if on the graph it's 2, on the equation will also be 2. So Q is equals to 2. So we find P and Q. P is -4, Q is 2. So let's find A. So far we have f at x is equals to a over x minus 4 plus 2. So we have to find A. So whenever there's one unknown, it's always easy to find it. So sometimes I can actually give you this as a question and say find A. So whenever we have one unknown, all we have to do is to just substitute a point. So we see a point in the graph which is 8 is to 3. So it means the y value is 3 and the x value is 8. So 8 minus 4 plus 2. So when we take this to the other side, it's going to be 3 minus 2, which is 1. And then A over 8 minus 4, which is 4. So whenever you have a fraction, all you have to do is to just cross multiply. So 4 times 1 is 4, and 1 times A is A. So A is equal to 4, so we found A. So it means the full equation is 4 over x minus 4 plus 2. That's our full equation. And we're done. So if you like this video, don't forget to subscribe to my channel and like the video so that you can receive more things like this.